guys, once again guys, we do a question here on electrical system modeling, and I read the question first. Prove that the transfer function of circuit is that when these two conditions are given. And so guys, we continue. So guys, we have our circuit right here, and guys, what we are going to do, we are going to take our current. That is the current that moves through here. We can use this loop here. And remember, this loop will take both of these. So, and here we have R2, we have R1 like that. So the first thing guys we need to recognize is what we call impedance. The impedance of a capacitor is given by 1 over SC, whereby 1 over SC is in Laplace transform. And so guys, already when we write that, we are already in Laplace transform. And for IR, current across R, we shall have IR R1. So therefore guys, for current across the capacitor, to be IC all over 1 all over C. 1 over SC. Guys, we are saying this is the impedance. It's actually the opposition to the current, and it's equivalent to resistance in DC. But remember, this one is taken in AC current, AC circuits. And so therefore guys, we continue. So we come and say, for the total current here guys, we will have current, use the Kirchhoff's law, whereby we have the IC here, we also have the IR here. If you add those two currents guys, we will have our total current at this. This is our total current. And guys, now we can write this in terms of the voltage and the impedance. Guys, for the impedance, remember for the resistance, it will still remain the same. The impedance is the same. And then we come for the voltage here. For the, of course, guys, here is V all over R gives us the current across R1. And then V all over this is the same as writing V over 1 over SC. This gives us VSC, and that's what I have written here. So remember guys, this is in terms of, this is impedance, and even R1 still does not change, so it still can be considered as impedance through the resistance. And so therefore guys, we can now come and factor out the V, and whatever we are left here is actually our impedance, meaning that is in form of Laplace transform. So this is equals to I is equals to V and that. So guys, from there we come and now write V is equals to I R1 all over R1 plus SC R1. That is for V. And guys, this is the voltage across this point, from at this point and at this point. And so guys, we know that for the total voltage, it will be VI input, it will be the voltage across that and also voltage across the R2. And that's what we are now having here guys. This is now voltage across the capacitor and the resistance R1, and this is the voltage across the R2, which is also the same as V0. Guys, as you can see, we can factor out the I because it is actually same for this term and this term. We factor out the I, we bring the I here, and then guys, we can combine these two equations, that this and this, we can add them together. When we add them together guys, we get something like that. And from there guys, we come and now say for V0 we have IR2, And remember guys, already this equation we have converted them into Laplace transform. The moment we took a capacitor, that is impedance, as 1 over SC, that is already converted to Laplace transform. And so guys, we just come and divide. That is V0 all over Vi. We divide that, and this is what guys we are going to find. And so therefore guys, this is our transfer function. But guys, we also need to prove this equation that is given here. This is the equation guys we want to prove. We want to prove that the transfer function is equal to that. Given these conditions, this is alpha equals to R2 all over R1 plus R2. J is equals to R1 multiplied by C. And that's what guys we are going to do. We are going to divide. For us to prove, we divide these two equations by R1 plus R2. So when we divide these two equations by R1 plus R2, guys, now we are able to find something like this. Whereby guys, we have divided this R2. We divide by R1 plus R2, guys, we are able to find the alpha, because you know that alpha is equals to R2 all over R1 plus R2, like that. So when we divide, guys, we find that. And then we are left with that. Then we go to the denominator. Guys, we divide the same for this. Guys, if we combine these two and divide, then this one is going to be 1. And then we also come and divide here. When we divide there, already we have R2, R1, R2 all over R1 plus R2. So guys, here we have alpha. And this is what we get, guys. This is what we are going to get as our solution. And remember that also we have the J, which is equals to R1 multiplied by C. It's still another condition that was given here. As you can see, J is equals to R1 multiplied by C. And therefore, that's why, guys, when R1 remained here with C, guys, we were able to convert that to J. The same case here, we have R1 and we have C. So this one is represented by J. And so therefore, guys, this is our transfer function. And thank you for listening to me. See you in my next video.